For decades, nuclear power was the thing we were all told to fear, right? But now, the biggest names in tech are in this frantic race to buy nuclear reactors. And the reason? Well, it's to power the single biggest tech revolution of our time, artificial intelligence. So, in this explainer, we're going to unpack the high stakes, kind of shocking connection between the AI boom and the sudden return to atomic energy.
Okay, so this really puts it into perspective. It makes an invisible cost totally visible. That simple question you type into an AI, to write an email or create a picture, that kicks off an insanely energy-hungry process. A single query might seem like nothing, but multiply that by billions of people making trillions of requests, and suddenly you don't have a small power problem. You have a full-blown crisis that's threatening to completely overwhelm the global energy grid.
All right, here's our game plan. We'll kick things off with the AI power paradox. Then we're going to try to quantify its unquenchable thirst for energy. From there, we'll dive into the wild solution that's being proposed, a nuclear renaissance. We'll ask if this is a bubble or a genuine breakthrough, and finally, we'll think about what it all means for our shared atomic future. First up, the AI power paradox. See, on the surface, AI feels like magic. It promises this seamless digital world where answers and art just appear out of thin air. But behind that digital curtain, there's this brutal physical reality. These systems need a staggering amount of power. It creates this huge gap between the promise of AI and the actual physical stuff needed to support it. And this brings us right to the heart of the matter. Is our ambition, our quest for smarter and smarter AI, pushing us back towards an energy source that, let's be honest, many of us thought we had left behind for good? This is the fundamental conflict we're here to unpack today. Now let's get into the hard data, because to really get why big tech is making such a dramatic and, frankly, expensive move, we need to understand the sheer scale of AI's energy appetite. And I have to tell you, the numbers are, well, they're truly staggering. Just let this number sink in for a second. 4%. We're not talking a 4% increase for the tech sector. No, this is a 4% increase in the entire electricity consumption of the United States, just to power AI data centers. It's like adding a whole new power-hungry state to the map, basically overnight. Our grid, it was built for slow, predictable growth. Now it's facing this insane demand curve it was never designed for. In the money trail, it tells the exact same story. $3 trillion. That's the projected global investment in data centers over just the next 3 years. This isn't just for buying more computer chips. No, this is a frantic global race to build the physical shell, the buildings, the cooling systems, the substations, the entire ecosystem just to keep the lights on for AI. And to bring that crazy number down to earth, just look at one company, a single player, OpenAI, the folks behind ChatGPT, are apparently planning to spend over $1 trillion in the next 8 years. That's nation-state level spending. The key thing here is that this isn't some short-term problem with an easy fix. It's a long-term, trillion-dollar reality that's reshaping the entire global economy. But here's where things get really tricky. It's the core technical problem. You see, we've spent decades building towards a future powered by renewables, like wind and solar. The problem is, by their very nature, they're intermittent, they're flaky, they depend on the weather. But the massive clusters of GPUs training AI models, they need the exact opposite. Perfectly stable, constant, high-density power 24/7. A flicker of power that lasts a fraction of a second can derail a training process that's been running for months, wasting millions of dollars. Our green grid just wasn't built for this kind of unforgiving workload. And this shows you the real-world consequences. This isn't some theoretical problem anymore. We are now at a point where a single tech company can walk up to a utility and financially outbid an entire city for its electricity. This is creating this unprecedented competition for a basic resource, threatening to turn electricity from a public utility into a luxury good. So all of this, it leads us right here to the main event, the nuclear renaissance. Faced with this colossal, uncompromising energy demand and the limits of our current grid, big tech is turning, and it seems like it's out of pure necessity, to the one source that can provide that 24/7, high-density, reliable power, nuclear energy. It's a move that would have been totally unthinkable just 5 years ago. So what exactly is this nuclear renaissance? Well, it's this incredibly fast pivot back to atomic energy. And it's not being driven by governments or traditional energy companies, but by the AI industry itself. They see nuclear as the only real way to fuel their relentless growth, turning them from just consumers of power into the architects of a whole new energy landscape.
This timeline, wow, it really shows you just how breathtakingly fast this all happened. For 40 years, after disasters like Chernobyl and 3 Mile Island, the world was basically in a nuclear winter. The industry was stagnant, just paralyzed by public fear and insane costs. Then, bam, the AI boom hits in 2022. And suddenly, in just a couple of years, we're in a full-blown renaissance, with tech companies, not governments, leading the charge. And let's be super clear about the level of commitment here. These companies aren't just signing long-term power contracts. They are fundamentally changing their business model. By directly investing in, and in some cases, planning to actually own nuclear reactors, they're becoming energy producers. It's a power play, literally, to secure total control over their energy supply.
Okay, but here's the big question. Is this a sustainable breakthrough, or is it just another symptom of a massive, hype-fueled AI bubble? We have to look at the potential risks and downsides of this all-in bet on nuclear, because, well, the consequences of getting it wrong are enormous. This quote, man, it just nails the biggest fear perfectly. What happens if the trillion-dollar promises of AI don't actually materialize as quickly as the energy bills come due? We could be left with a landscape of half-empty, power-hungry data centers tied to nuclear plants with 60-year lifespans, and the monumental, multi-generational debts that come with them. So let's break these risks down. The whole thing feels a little bit like putting the cart before the horse, right? We're building massive, permanent energy infrastructure for a technology that is still, in many ways, trying to find its economic footing. You see the scary parallels to the dot-com bubble, which saw colossal spending on fiber optic cable that then just sat dark for years? If AI hits that trough of disillusionment, which is a standard phase in any tech cycle, these huge investments might never turn a profit. And that creates long-term systemic risks, not just for the tech companies, but for our entire power grid. Which raises a really fundamental question. Is this even sustainable? We're trying to bolt the future of artificial intelligence onto an energy infrastructure that was designed for the last century. There is this huge foundational disconnect between the power-guzzling design of AI data centers and the kind of grid we were supposed to be building. And that brings us to our conclusion. Our atomic future? We've seen the problem and the proposed solution. Now it's time to step back and weigh the incredible promise of AI against the very real peril of how we choose to power it. Ultimately, when you boil it all down, this is the stark, strategic choice the AI industry believes it's facing. On one side, there's the very real possibility of its growth being completely throttled by energy shortages, a kind of digital blackout. And on the other, a full-throated return to a powerful but deeply controversial technology that we've spent decades debating. So I'll leave you with this final thought. Is this unprecedented pivot to nuclear power a brilliant, forward-thinking move to secure the foundation for the next technological era? Or is it a desperate, high-stakes gamble on a technology that could change the world, or saddle us with an atomic infrastructure we can't afford and didn't really plan for? The answer is going to define our world for decades to come.